Allison Dowda from A Double Dose of Dowda, and let's talk about how to teach students how to add and subtract mixed numbers with like and unlike denominators. We are going to go through everything you need to know about the standards themselves, about how we can teach these in the best possible way, and how to differentiate once we have taught the lesson to students. So let's jump in. The first thing that we want to go over is the progression of the standards. It's important to know where students are coming from and where they're going next. So when it comes to adding and subtracting fractions, in 3rd grade, students learn just their basic fractions information. They learn about identifying fractions, they learn about comparing fractions, they learn about equivalent fractions, all in 3rd grade. Then, for most states, in 4th grade, they talk about like denominators, adding and subtracting fractions with like denominators, to be more specific. And then in 5th grade, they learn how to add and subtract fractions with unlike denominators, including mixed numbers. It's worth noting that 5th grade is the end of when students will work with adding and subtracting fractions as part of their standards. Moving on from that, they are expected to just know that. So that's why we need to make sure that students have a firm understanding and a firm foundation in how to add and subtract fractions in 3rd, 4th, and 5th grades. Whenever we teach something, we certainly want to take a research-based approach. So we are going to talk about this strategy called the CRA model. This is when we say that students need to learn something first in a concrete way. They need to have hands-on experience and exposure. They might be using manipulatives, something that they are touching and feeling and really understanding how the concept works. R is the representational model. So at this point, students need to be drawing pictures or seeing pictures and representations. They need drawings, something where it is very visual for them. And lastly, we are going to talk about the abstract model. So this is one where for abstract, there's no hands-on, it's just equations and algorithms. No extra helps are included whenever we use the abstract model. For our purposes in this video, for CRA modeling, for concrete, we are going to show students how to add and subtract mixed numbers using pattern blocks and fraction bars. For representational, we will be using pictures and number lines. And then for abstract, we are going to just use written equations. I like to mention at this point that students need time to work through each of these models. This is certainly not a one-day lesson that I'm about to share with you. Rather, this is something that will build across some time. Some students may be ready to jump to representational or even abstract more quickly than others, but I encourage you, do not leave out the concrete modeling for this concept of what is happening when we add and subtract mixed numbers. So let's jump in and get started with the demonstration. The manipulatives that I like to use with fractions are those that I have already shared in previous videos. I absolutely love fraction bars, also called fraction tiles, as well as pattern blocks for all things fractions. Today, as we are going to be talking about adding and subtracting fractions that are mixed numbers with like and unlike denominators, these are going to be a little more involved as far as the problems go. So I am only going to choose one of these manipulatives to show today. I'm going to focus on pattern blocks, but know that you can do these same things with fraction bars. If you are fortunate enough to have one class set, then you will only have a whole for each student. So this is a great opportunity when you're working with mixed numbers to have partner work or small groups of students working together. Now, traditionally, whenever I'm using manipulatives, I really limit the amount of writing that I do of the equations and things. I want students to be able to see things, but I don't want them to get too distracted by them. However, today, students should already be quite familiar and proficient with adding fractions with like denominators and adding and subtracting fractions with unlike denominators. So if you need to review those things with them first, by all means do that. But our first problem that we are going to work today with manipulatives is 2 5/6 plus 1 1/3. So I'm going to begin by getting my pieces out for this. I have 2 and 5/6 all set and ready. I mentioned this in previous videos as well, that I do really like to have a poster or something at the front of the room as a reference so that students can recall very quickly that this is 1 whole, 1/2, 1/3, and 1/6. And that just helps the lesson move along faster. So we have 2 and 5/6, which is shown here. And now we need to add 1 and 1/3. So here is 1 and here is 1/3. Now we need to combine these. What I want for students to realize first is we've talked a lot about how we need the pieces to all be the same size in order to combine them. However, when we have the whole numbers, we don't necessarily need to break those apart in the beginning. That will cause an extra step at the end. So I tell students, let's, instead of focusing on the whole numbers, let's just focus on the fraction pieces. I have 5/6 and 1/3, and I'm going to want to combine those pieces. So I need to start with thinking, okay, what can I do to get these to be the same size pieces? Now, as students think through, they may say, well, let's try the blues first and let's see if we can get everything to be a blue. So I can get 2/3 on there, but then there's still that 1/6 piece that isn't going to be covered. So we are not going to change 1/6 to 1/3. So hopefully they will come up with the idea instead of let's change the 1/3 to 1/6. And they should be familiar with fractions and how these pieces work already. So they should know pretty quickly that 2/6 is going to give them the same thing as 1/3. Now, this is the part where I do like to have students, just so they can see what we're doing as we go along. I do want to rewrite some of these fractions. 2 and 5/6. We did not change 2 and 5/6. So when I rewrite this piece, I'm going to leave that the same. It's going to remain 2 and 5/6. Now, another thing that I like to do whenever I write my fractions, whenever I'm having to rewrite equivalent fractions, I do like to stack them on top this way rather than writing outside here equals 2 and 5/6 plus, because sometimes students just visually, that's a lot of numbers and can be kind of a mess. So I like to write it underneath 2 and 5/6 plus, remember that one stayed the same, but 1 and 1/3, we did rename that fraction and we renamed it to 1 and 2/6. So I'm going to move my pieces down a little bit out of the way. And I have now, instead of 1 and 1/3, I have 1 and 2/6. So 1 and 2/6. And I like to sometimes put a little arrow there so that students can recognize that's one that changed. This one stayed the same. We did make an equivalent fraction for this one. So I like to, once they do the swap out, I like to get rid of that extra piece that they stacked on top because I don't want any confusion later. Now I ask students, can we combine 2 and 5/6 plus 1 and 2/6? And they will pretty quickly be able to tell you that that equals, we have 3 wholes right here. So I'm going to put that it equals 3 wholes. And then on this one, if I combine 5/6 and 2/6, well, what do you know? That makes 1 whole and 1/6. So I'm going to have them actually physically write out 3 plus 1 and 1/6. And then they will know in this case that it is, what's a better way to say that? What swap can we make? Well, we can swap 1 whole for the 6/6 there. And that leaves me with 4 and 1/6. You may also choose in this step, instead of having them write 3 plus 1 and 1/6, maybe a better way to have done that would have been 3 plus 7/6 or 3 plus 6/6 plus 1/6. But for me, I think for most students, this should make sense at this step, but you can certainly break that down further. So our total answer for this one is 4 and 1/6. And this was working it out using pattern blocks. we're ready to move on to a subtraction problem. Now, not all subtraction problems are going to be as difficult as this one that we're about to do. I would have you first do some simpler subtraction with mixed numbers problems that don't require regrouping. But we are going to jump right in to a question that is going to involve some regrouping. So let's say that my problem now is 2 1/6, and I am going to take away 1 1/3. Now, in this problem, we are going to start by building 2 1/6. So let's build 2 1/6. All right, now I need to take away 1 1/3. Remember, if you're working with pattern blocks or anything else with students, whenever you are taking things away, sometimes students are going to want to say, okay, 1 1/3, and they're going to like add this to the problem with it. We don't want them to do that because that's going to cause confusion. Instead, we say we are going to take away 1 whole and 1/3. And let's have a quick conversation about this. What would be difficult, I would ask students, about taking away 1 1/3? What would be easy and what would be difficult? And they probably will tell you that taking away 1 whole is easy, but the problem is taking away 1/3. Why is that difficult? Because right now we just have a whole and we have a 1/6. And so how can we take away a 1/3 from that? We need to rename some of these fractions so that they can look a little bit different and a little bit more friendly. So we need to think, what can we do to get things to the same size pieces? Now, some students may come up with the idea of, well, we need to take away thirds. So what if we did a fair trade, and instead of having a whole, could we do swapping out for thirds, because later I can take away 1 1/3? Well, the problem with that, take that idea if students give you that idea, but that is going to be a little troublesome in the next step. So listen to that idea, ask them if there's something else that they could do, what would be some other possibilities, and just field all of those ideas. So what we want them to come up with, and for the very first time, it might be helpful for you to just tell the answer. Maybe it's less of the exploring and more of telling. And telling them that, well, I'm thinking we have 1/6 right here, so let's do something crazy and let's make everything into 1/6. We're going to do that fair trade. So I'm going to take 1 whole and swap it out for 6/6. And then going to take this next one and also swap it out for 6/6. And I'm going to ask students at this point, okay guys, let's really think about this. What have we just done? We have renamed 2 1/6 into something else. We haven't changed the value because it's still 2 1/6, but what's the appropriate name for what we have done here? Well, we have 6, 12, 13, 1/6. So let's rewrite that as we have renamed it. I draw the arrow down, and I have 13/6. As the teacher, notice here for a moment what you have done is you have set this up for the algorithm later when you teach them to multiply the denominator times the whole number and to add the numerator. That's what we've just done, but now they're actually seeing what's happening. I would not teach them the algorithm yet. This is all about them seeing what's happening. So 2 1/6 has been changed to 13/6. Then I'd have the conversation with them. Okay, guys, great. We did a great job on this one. Now we need to take away 1 1/3. Can we take away 1 1/3? Well, there would be 1, and then a third would be here. But what do I need to rename this as of what I'm taking away? I'm actually going to be taking away this piece, right? So how can I say a different name for what I'm taking away? Well, I have 6, 7, 8. I have 8/6. That's the same thing as 1 1/3. So 1 1/3. I'm going to subtract those from one another. Now, notice on this one, at this step, we have two improper fractions with like denominators. In this case, we're just taking away 13 was our total, and we are taking away these 8. How many sixths do we have left? Going to put them together, and we have 5/6 left. Now, I know that for teachers, this can be a little overwhelming to think about, because you think, well, we just need to turn these to improper fractions. Like, you want to jump straight to the algorithm, but that's not what's most appropriate for students. They need to see this. They need to see what is happening. So here we are left with 5/6. That is our concrete way of teaching this. Now we are going to move to representational. So to move from concrete to representational, I still like to incorporate my little pieces to go along with that. So the next problem we are going to do with pictorial representation is we are going to do 1 1/6 plus 1 1/3. Now, on this one, I love to have students still have these pieces in their hands whenever I move from concrete to representational. In this case, I'm going to only choose to use pictures for this rather than a number line, because 2 reasons. One, as you've seen, sometimes problems can get a little bit messy, and so the number lines give some clarity, and the pictorial, I think, just works better, helps it to get less fuzzy for them. But also, I don't know about you, but my students are not great at drawing their own number lines. And even with the tracing and things that I like to do, it can just get too big. So instead, I am just going to use pictures, and I am going to stick with my pattern blocks. So 1 1/6 is what I'm beginning with. I like to have students trace these pattern blocks. We've already gone over them. So I'm going to trace 1 whole, and I'm going to do 1/6. Now, in order to do 1/6, you do have to trace the next piece. And yes, you might get a little marker around your pattern blocks, but you know what? That is fine, just fine. So I have 1 whole, and I need 1/6. So in this case, sometimes I like to just have students do the first one at least, so they can see and kind of prove to themselves, okay, this is the size. And then and 1/6. So I'm going to draw in my 1/6. Now, for me, one thing that I do like to do is these pieces that we've been working with, that they are familiar with, the 1/6 piece is green. So whenever I color it in on my picture, I'm going to color it in green, just because I'm a visual person and I like having that association. And I'm going to, since the big tiles were yellow, I'm going to color this in yellow. So here I have 1 1/6. Now I am going to be adding to that 1 1/3. What I want to do on this one, in order to add 1 1/3, I don't want to jump ahead and start drawing extra things. Instead, I want students to think about this process first. Think about if I add 1 whole, okay, you can picture that, but then to add 1/3, some students are going to know, well, that would be a blue piece right here. You're right, it would be a blue piece right here. However, the way that we have it drawn, I don't want them to skip this step. I want them to make it into 1/6. So I would say, all right, you're exactly right. 1 1/3, that would be the same as adding this, but how can I mathematically write what I'm doing here if this is a third? I want them to come up with the idea that instead of saying a third, that's the same thing as 2/6. So again, I'm just going to rewrite this and keep up with what we are doing. I would have 1, but 1/3 is the same as 2/6. So I'm going to rename that fraction as 2/6. Now, whenever I add my 1 whole, I just add another piece here. and I add 1 whole. And next, I need to add my 2/6. So here's 1/6, here's 2/6. So it equals 2 and 3/6. Now I would ask them again, okay guys, looking at this, what's a better way to say this picture mathematically? Instead of saying 2 and 3/6, it would be simpler to say 2 and 1/2. So our sum is 2 and 1/2. Now, this is, again, just like I said with the concrete model, with using the pattern blocks and hands-on, this drawing piece, there can be a lot to it. But what this is going to do is it's going to help students to better understand once they get to the algorithm. Once they get to that abstract piece, they're going to have a sense of why they are doing some of the things that they are doing. We don't want them to live here forever. Some students may take longer at this phase and need to draw things out, and that is just fine. But we just want to give them the opportunity so that they can help understand and bridge their learning as they go along. So now for this last one, I am turning my paper over because I need a little extra room for this one. This one is a problem that we worked previously with the pattern blocks, but now we are going to do the algorithm for this. So I have 2 and 1/6, and I am going to take away 1 and 1/3. Now, for the algorithm, you will teach the students that the shortcut here from all the things that we did before is to multiply the denominator times the whole number, and then you add the numerator. You talk them through this by reminding them that in the picture, when we had 2 wholes and we changed them to 6th, then that gave us the 2 wholes was 12, and then we had 1 extra, so we have 13/6. And we are taking away, on this one, we need to change this one also. We are doing 3 times 1, which is 3, plus 1 equals 4 over 3, because our denominator stays the same. So on this one, the problem is, again, we can't subtract, unlike denominators, unless we change to an equivalent fraction. So 6 is going to stay the same, so I still have 13/6, and I'm going to be taking away, I need an equivalent fraction, so 6, that will be 8. 13/6 minus 8/6 equals 5/6. And so that's the progression of going from concrete to representational to abstract in solving this problem. Oh, and I forgot, I did make a change there, so I do like to draw that arrow there. Now you've seen what each of these approaches look like. They've been modeled for you. The next thing I want to share with you is something I like to keep in mind whenever I'm teaching a lesson. What are the milestones? What are the big pieces that I need to make sure that students are solid on? This can help me to know when they're having trouble. I can pinpoint, okay, what part of the process are they having trouble in? So when we're talking about adding and subtracting mixed numbers, our milestones are these. We want to make sure that students can use least common multiples to develop their least common denominators. We need for students to really understand equivalent fractions, because when they are converting their fractions into the equivalent fractions with least common denominators, they need to be able to do that correctly. A new skill whenever we start talking about mixed numbers is this idea of regrouping the fractions or the mixed numbers, so that we are writing those fractions in a different way, writing those mixed numbers in a different way, as you saw modeled in the video. We need to make sure that students are clear that they only add and subtract the numerators, that the denominators stay the same. And then lastly, we want to be sure that they understand simplest form, just that final touch. Oftentimes, this is something that students will struggle with, this milestone of making sure that their answers are in simplest form. They can do all the other stuff, but they just miss that. So when we can break things down, it really helps us know how to plan for our instruction. The next piece I want to talk about is differentiation. So what do we do if students are struggling or if they're really successful? The first part for differentiation is for those struggling students. What might some interventions be that students need? In these cases, these are skills that probably go before your current grade level, but they have to be able to do these things really well, like adding and subtracting like denominators. That's something that if students are struggling, they might need a review and some work to fill in those gaps to make sure that they are adding and subtracting their like denominators correctly. The same thing with equivalent fractions, as well as regrouping fractions. When we are talking about mixed numbers, specifically about subtracting with mixed numbers, there's a lot of regrouping that needs to go on. So that is certainly an area that you may need to focus on with your differentiation for struggling students. Now, if you have students that need a little bit of a challenge, here's some areas that you can enrich your instruction in their practice. Maybe you have those students start adding and subtracting 3 different mixed numbers rather than just 2. Throw another 1 or more in there. And then lastly, for differentiation, you can start to combine adding fractions and decimals with these mixed numbers. So that's something that is a skill that they will need later, but for now, that would be a great area of enrichment and challenge. In case you are looking for some practice that I know your students will enjoy, I have put together a little bundle of activities all about adding and subtracting mixed numbers that includes regrouping. There are 6 resources. 4 of them are worksheets, and there's a matching game as well as an anchor chart. I have 4 maze worksheets for adding and subtracting mixed numbers, both with like and unlike denominators. So this is an area also for differentiation where some students may not be ready to move on to unlike denominators yet. So you might give some students like denominator worksheets and other students the unlike denominators worksheets. But there are 4 of those included. There is a matching game. This is also differentiated. In this case, it has 3 levels, as all of our matching games and task cards do. But the lowest level is for below level learners. The yellow level, the middle level, is for on-level learners. And then the pink is a challenge. The pink level does include mixed numbers and some regrouping of fractions. So it can certainly be a challenge for students. Lastly, I have an anchor chart for subtracting mixed numbers. I do have one just for adding and subtracting fractions with unlike denominators, but specifically, this one is for subtracting mixed numbers. What I think you will like about this is there is a full-page printable sheet for the anchor chart. There are also half-sheet versions, so if you use interactive notebooks, these are perfect for those, as well as a poster version. So it's set up to print on 4 pieces of paper that you can tape together and make one large poster out of that can be seen across your classroom. You can find this add and subtract mixed numbers activities bundle in the link in the description below. Also linked in the description below is a free download for a handout for everything that we talked about today for how to teach adding and subtracting mixed numbers. That is a great tool just to print and stick with your lesson planning materials and to have handy whenever you are ready to start teaching this skill. I hope that this video is valuable for you in better understanding the progression of the standards, how to teach adding and subtracting mixed numbers in a meaningful way, as well as how to differentiate for your students.
As always, thanks for watching, and we would love for you to subscribe to our channel.